Hi everybody, today we're going to look at solving quadratics by completing the square. And so remember how we solved these types of questions when we solved by square roots. When something is squared, like we have here, we know that we can square root each side and solve this problem. And so the square root cancels the square, so I'm left with x minus 3 is equal to plus or minus 4. Anytime that we're solving and we take the square root, we have to have plus or minus. And so if I add 3 to each side, that gives me plus or minus 4 plus 3. And so that simplifies into 4 plus 3 and negative 4 plus 3 because we have positive 4 and negative 4. And so I get that x is equal to 7 or negative 1. And then we have to check our answers and make sure that both of those answers will work. And so if I take 7 and plug it in, 7 minus 3 is 4. 4 squared is 16. And if I take negative 1 and substitute it in, I get negative 1 minus 3, which is negative 4 squared, is still positive 16. And so these are both appropriate answers. And so here on the next one, I can take the square root of both sides, and I'm left with x minus 3 is equal to plus or minus 5i from those imaginary numbers. And so I get that x is equal to 3 plus or minus 5i. And those are your two separate answers. You can write it as 3 plus or minus 5i, or you could say 3 plus 5i and 3 minus 5i. And those would work as well. And so we're going to be using this process when we complete the square. There's going to be a little bit of missing information that we have to figure out. And so here, I know that I can solve this one by factoring because I just need two numbers that multiply together to give me 25, that add together to give me 10. I know those two numbers are 5 and 5. And so this factors into x plus 5, x plus 5. Or we could rewrite that as x plus 5 squared equals 0. And I can take the square root of each side. And so I get x plus 5 is equal to 0. And so that means that x is then equal to negative 5. And so what we're going to be doing is we're going to be missing this piece of information right here. And we're going to have to find what number works so that I can rewrite this entire side as something squared. And in this case, it was the x plus 5 squared. So here's another one. I'm going to set this equal to 0. So I'm going to say x squared minus 12x plus 36 is equal to 0. I can solve this using factoring. And so I'm going to need two numbers that multiply together to give me positive 36, that add together to give me negative 12. And I know those two numbers are going to be x minus 6, x minus 6. And so I can rewrite this as x minus 6 times x minus 6, or I can rewrite that as x minus 6 squared. And that's what we're going to be doing. We're going to be writing things in this format so that we can solve it from here. So if I take the square root of each side, I get x minus 6 is equal to 0, and I get that x is then equal to positive 6. And so like the last two problems that we just did, I told you we're going to be using that format and trying to get it in this form. And so I have to think about what number could I put inside this box to make this entire thing a true statement. In other words, I want to rewrite this as x plus 2 squared is equal to x plus 2 squared. And so on the left-hand side, if I FOIL that out, x plus 2 times x plus 2, I get x squared minus or plus 2x plus 2x plus 4. I get x squared plus 4x plus 4. So this is the number that we're looking for, that 4 right here. So now I know I can come in and put 4 here, and then this is a true statement. And so the way that we're going to find that number, I'm not going to ask you to do all this work every single time. We're going to take half the middle term, we're going to take half the middle term and square it. And that is the number that's going to go right there. And so the middle term is this 4x and so I take that 4, divide it by 2, and square it. So 4 divided by 2 is 2, and 2 squared is 4. And that's how we come up with what number goes, quote unquote, in the box. Okay, so here, how could I make this one true? Well, if I take half the middle term and square it, -6 divided by 2 is -3, and -3 squared is 9. And so what this is enabling us to do, it's enabling us to be able to write this as x minus 3 squared. And then we have a true statement. So what number could I put in the blank to make this true? So I'm going to take half the middle term and square it. So -8 divided by 2 is -4, and -4 squared is +16. So +16 can go in our box. If you want to think about it, like we did at the very beginning, if we took this and factored it, I would need two numbers that multiply together to give me 16, that add together to give me -8. And those two numbers are, of course, -4 and -4. So that enables us to write this as x minus 4 times x minus 4, which is x minus 4 squared. So it's just kind of a shortcut to get in this format so I can solve these equations. So now we're going to talk about how we can take what we just talked about and solve these quadratic equations. So if you notice, sometimes we are given quadratics that are not factorable. So like for instance, this problem right here, I would need two numbers that multiply together to give me 11 that add together to give me -14. Those numbers don't exist. And so we have to use another format. We have to use the completing the square, or we could use the quadratic formula to solve these. So the first thing that I'm going to do is I'm going to put it in the right format. So I need x squared minus 14x plus a box and that's going to equal negative 11 plus a box. Because remember, whatever we do to one side of the equation, we have to do to the other side of the equation. So I subtracted 11 from both sides to get it in this format. So now I have to decide what goes inside the box. Well, that's where we come up with our middle term divided by 2 squared. So negative 14 divided by 2 is negative 7 squared, which is positive 49. So if I add 49 to the left-hand side, I have to add 49 to the right-hand side. Now we're in the right format so that I can take the left-hand side and rewrite this as x minus 7 squared. And 49 minus 11 is 38. So I can now solve this equation. I can take the square root of both sides. So I get x minus 7 is equal to plus or minus the square root of 38. I don't know if 38 can be simplified. I don't believe it can. And so if I add 7 to both sides, I get x is equal to 7 plus or minus the square root of 38 as my answer. And you can just leave it just like that. And so if you take a step back and you look at what we've done, I moved 11 to the other side. I completed the square. In other words, I found what I could put inside the box. I quote unquote factored the left-hand side, and then I solved it using the square root property. And so we would have never got that answer had we tried to factor it. There was just no way that we could use factoring. And so you have to have some other method. And completing the square is one of those. So here I'm going to put this in the right format of x squared minus 2x plus a box is equal to 2 plus a box. Notice that your constant is on the right-hand side. I'm going to figure out what goes inside the box by taking half the middle term and squaring it. Make that look a little bit better. Well, negative 2 divided by 2 is negative 1, and negative 1 squared is 1. So 1 goes inside my box on both sides. That enables us to write the left-hand side as x minus 1 squared is equal to 3. I can use the square root property to solve. So x minus 1 is equal to plus or minus the square root of 3. And if I add 1 to each side, I get 1 plus or minus the square root of 3. And those are my two solutions. And again, you can write this as 1 plus the square root of 3 and 1 minus the square root of 3, or you can just leave it as plus or minus. Okay, I want you to pause the video and you try to do this one on your own and then come back and check your answer. And so you can see that we get x is equal to negative 4 plus or minus 3i. When I found that what goes inside the box, I took half of 8, which is 4, and 4 squared is 16, and that's where our 4 comes from. So here's another one that would not be able to be factored. So I'm going to set it up in the right format first. So what goes inside my box? I take half the middle term and square it. And 2 squared is 4, so 4 goes in my box. That enables us to write the left-hand side as x plus 2 squared equals 3. When I square root both sides, I get x plus 2 is equal to plus or minus square root of 3. Moving 2 to the other side gives us x is equal to negative 2 plus or minus the square root of 3. Here's another one. This one's going to be a little bit trickier. I'm going to put it in the right format first. Notice I'm adding my 1 to each side to get that constant on the right-hand side. So what's going to go inside my box this time? If I take 3 divided by 2 and square it, that gives me 9 over 4. So 9 over 4 is going to go inside my box. If I do it to one side, I got to do it to the other side. So that means that this side could factor into x plus 3 over 2 squared. And let's see, 9/4. If I get a common denominator, I get 13/4. And when I square root both sides, I get x plus 3 over 2 is equal to plus or minus the square root of 13 over the square root of 4. You can split that up into the square root of 13 divided by the square root of 4. And the square root of 4 is 2. So that gives me plus or minus the square root of 13 over 2. And then I can subtract the 3/2 from both sides. And I get negative 3 over 2 plus or minus the square root of 13 over 2. Now you could even write that as negative 3 plus or minus the square root of 13, both of them over 2, because they have a common denominator, but it's not necessary. You can write it either way. Just be sure to pay attention to my math lab and the directions on how they want you to type your answers in, because they're pretty specific most times. All right, I hope this video helps. And if you have any questions, as always, let me know.